Okay, yep. So welcome to the Python class. It'll be every Wednesday this month, the same time and same place in the building, or just on Zoom if you want. And I'm taping this, and if you need to miss an additional class down the line, you can just let me know, and I will tape those as well, and I can send out that in the handouts, so you don't miss a lesson in the middle and feel like you need to drop out because you missed some foundational stuff. Okay, so we'll just hop straight into it. If you have any questions, if you want me to slow down and explain something again, anything like that, you can just feel free to unmute, or just put it in the chat, and I'll try and keep an eye on the pop-ups of the chat. Okay, so Python is a programming language. So I'm just going to talk a little bit about what it can do, and then we'll kind of get into it. So what Python can do, it can do kind of anything that you can imagine most programming languages doing. What we'll be looking at in this introduction class is basically all the foundational stuff, the types of data objects, dealing with quantities and text and things like that, and then what we can do with them, running calculations, doing things based on logic, if this condition, then we'll do that, and so on, and things like that. And then everything else in this bullet list is kind of the heavy duty stuff that it definitely can do, and things beyond this, but obviously we won't have time to get to in this class. But Python can basically do it all. It's one of the most used languages nowadays, and it is that because it's so easy to pick up if you're new to coding at all, and easy to use in that way. So it can do like data analytics and visualizations. You can build like AIs and things like that, machine learning, all those types of complicated things that people talk about, big in tech, and businesses use them and things like that. It can be used as like kind of the back end of a website if you need to build a website and have people log in and maintain a database and things like that. Python can be a component of that website. And some of those would be called like Django and Flask. That's kind of the tool with the type of Python that you would use to build a website. You can make video games, you can build different types of apps and phone apps and all kinds of apps. You can do things like web scraping, basically all kinds of stuff. Lots of big companies use it. Google uses it, YouTube, Reddit, Pinterest, NASA, Netflix. They all use it to some extent. They might not use it to, run all of Google, but different big projects. And I think Pinterest itself runs almost completely on Python and Django to build its website. So they use it to different extents. And the reason so many companies and people use it is that it's quite human readable. We'll see some examples of it in a second. It's not zeros and ones. It's not a lot of complex ideas you need to pick up from the beginning. We can kind of pick it up straight away, and it just kind of reads like plain English. And that's why it's one of the most used languages, and one of the ones that people new to coding pick up as an initial language. So today and in the rest of the class, we will be in replit.com. So it's basically a website that is an application that we can write Python code, execute and run the code, and then just like save the Python files so we can come back to the website, log in, and see all the projects and notes and examples that we've done. So Replit is an example of an IDE, and that's basically an application to run code. And all types of languages use IDEs. It's not just Python. So it's the equivalent of like Microsoft Excel is the application to write and execute spreadsheets, and IDE is the same type of application just to do programming languages. Most IDEs have to be like downloaded and installed on a laptop, things like that, but we don't want to deal with any of that. So this is just website based, so we don't need to do any complicated installs, and people won't be left out if they get stuck. So if you haven't yet, make an account or just log into Replit. This is what the home page looks like. And what we'll need to do is click on the create button, and it's going to make a project basically. And in Replit, you can do all types of languages. You can do like a mini website with HTML, CSS, and JavaScript. If you scroll down these templates, you can basically choose any language to make a project in. put it on the website and kind of host it. But we'll just need Python. So if you don't see Python in the list, you can just type it in, choose Python as the template. That means we'll be writing code in Python. And then you can just title it kind of anything you want. It's just the title of the project. So I'm just going to, name mine like this, and then I'll just make it by clicking create. And then I'm going to skip this this box, just explaining the thing to me. So we'll just quickly look at this page. So this is my code box. We have a couple things on this page. On the left-hand side, we have a file management system. And the file that I'm in now, this main.py, that's what we'll be making the code in. Python in all languages. It's just a text file. And the extension, instead of like .text or doc or XLSX, like spreadsheets, it's just .py in the case of Python. So we'll be using main.py. As we go on in the class, we might make a second file. So we have a class 2 file and things like that, but we'll just stick with main.py today. So that's my files on this side. We don't need to deal with the tools and these couple things down below. In the middle, obviously, is my Python file. So we'll be putting the code in this box in a little bit. And then on this side, we have 2 things. The console is a way of writing Python code kind of on the fly. So instead of putting the code in the file and then saving it and then running it, we can just kind of write Python code on the fly and then do that in the console. So this is some Python code. And we'll do that a couple times. And then the shell is something that we won't quite deal with in this class. Maybe class 2 and 3, but we don't need it today. So we'll just stick with the console today. Okay. So let's have this little image, and this is basically showing what I've just done. I just wrote in Python to print out a message called hello. And this graph or this image is basically the same thing in all kinds of different languages. So we can see Python in the middle, print hello with parentheses and some quotes. Pretty simple to do that. But we can see why Python is well used, and it's easy to pick up, because some of these different languages, you need a whole lot of code just to print a simple message. If you look at like C++, this looks quite complicated, all these things, lots of different punctuation symbols, indentations, all this kind of stuff. So if we look at this, we can get the kind of gist of why Python is easy to use. And that goes on to this point. So this is this block is an example of a bit of Python code. And if you just take a second to look at it, you can kind of read it top to bottom, just kind of like plain English. And you can begin to get a feel of, kind of what it's doing without even knowing any Python code. So it's pretty readable in that sense. So we see something called pocket change. We might not know why we have these specific types of brackets and things, but it looks like I have maybe what we'd call some data. And it looks like we can make sense that it's, some coins in a pocket, dimes and nickels and things like that. Then we make something, again, we'll call it data at this point, that we call total. And then we see some like syntax that'll be specific to Python, the kind of sentence that we'll have to know how to build. But, we can kind of get the sense that it's saying for each coin in that pocket change data that we just made, let's add that coin to the total. And then we can kind of make sense. At the bottom, it says print out total is equal to, the total that we calculated. So it'll take a bit until we know how to make data objects, what types of like brackets that we need and when to indent and things like that. But it's pretty easy just to begin with off the cuff. So some basic syntax rules that we'll kind of keep in mind as we pick up the code. Each line of Python usually just contains like a single code instruction. So if we take a look at this again, this top line is just making a data object. This one, total equals 0, that's also just making a data object. So we have them on separate lines, top to bottom. And then we have a couple lines below it, and they just do one thing each. So we can kind of use that to keep things simple. Indenting is mandated in Python. So the fact that I have this little indent on the total plus equals coin line, that's something that we have to do. And if we miss that, it'll kind of break the code. So when I mentioned now we need to indent, you'll need to do that, and I'll explain why when we get to that. Python is pretty punctuation and symbols limited. It's mostly symbols that we know, equal sign, the math signs like plus and minus and things, quotes, commas, and, brackets, but that's basically it. Again, it's not like that like C++ language we saw in that image up above, and all kinds of different symbols, all about. So it's pretty limited in that sense. And it's basically just plain English. We get to name all the objects that we make. So we can just call things pocket change if that's what it's actually symbolizing. So it's easy in that sense. We can name things sensibly. We talked about bugs. So not only if like we miss the indentation when we need it, if we miss like an equal sign, if we don't close a bracket, that's when Python might crash. Because Python, like most languages, it's the point of it is that it's really fast and can do like 1 million calculations in a couple seconds if we want. But we have to be really explicit in telling the machine exactly what and when to do things. So even if we miss a single symbol, it won't know what to do, and it'll ask us to fix the code, and then we can go on. Okay. So this little diagram, and we can see this looks like my console in Replit. So I can actually do this, and you can do it too. I can come to my console, use what's called the help function, which is built in. It has a built-in result. This is basically a list of all like the key vocab that we need in Python. And you can see it's not that big at all. Some of these things we won't get to, and maybe won't make sense to us, like lambda and non-local. Those seem, techie and kind of confusing, but most of this is just plain English, false and true, await, continue. Def just means define. We have things like if and finally, else, in, from, pass. So it's a lot of it's just plain English. So once we get to it, it'll be kind of easy to see what it's going to do. And that's basically all that we need to memorize, besides, when to indent and the punctuation symbols and things like that. The rest of Python, as we saw a second ago, is things that you name. So when we make custom functions, anytime we make a data object to hold some value, that's things that you get to name. So a lot of Python is going to make total sense to you because you made half of the things. And then you just need a couple symbols and things like in equal signs and things like that. So it's quite limited in that sense of not needing to memorize a whole lot. So that's easy for us. Okay, so we'll go ahead and begin to actually continue to pick up some basic code now. So I'm just going to minimize this a little. I'm not going to use my main.py file yet. I'm just going to do some code in the console. So you can actually, minimize these windows so you can make space if you want. I'm just going to do it so we can see the slide at the same time. So in my console, we'll just begin with basic math. And as we can see from the image in the slideshow, which we'll just replicate in a second so you get the feel of it, when it just comes to basic math, it looks exactly like math you would do by hand, by pencil. So you just use the values that you need, use the math symbols, and it'll calculate out what we want. So we have addition, we can do subtraction, division is the slash symbol. And one thing that we'll notice as I'm doing this is that I'm not being exactly consistent with my spacing. With this one, I did 2 + 2. And then in this one, I had 100 space minus space 50. And this one, I also wasn't consistent. This, when it comes to Python, you don't have to be consistent with this. The white spacing in between doesn't really affect anything. It's usually best to stick with one type of spacing and just do it to be consistent. And the kind of convention is like this. Just put a white space between everything like this. So if we went back and did everything again, we would want to kind of put a space between everything like that. So we have the basic math symbols. We also have some additional ones down this way, like a special type of division, modulus, if you know what that means, which we'll use at the end of the series. So we'll come back to that, but we don't need it quite yet. And then we also just have parentheses so we can follow like PEMDAS and things like that. So if we kind of combine them all, I can use parentheses and say like 2 plus 7 divided by 3, and then it's going to do that math. And that's going to be different from if I do this, because I'm using the parentheses to say do the 2 plus 7, make 9, and then divide by 3, as opposed to this, which is do 7 divided by 3, and then add the 2 to it. So that's just basic math and basic PEMDAS. That's not Python specific, but it's good that we just follow those math conventions, which most of us have a feel of, and it just kind of translates directly into Python. Yeah, so that's just in the console. So we did that. It's just kind of calculating it on the fly. It's not saving this in any way. It's just printing it out once we do one line of code. So the console is really just to test things out and to kind of do things on the fly. Obviously, when we write Python, we'll want to make all kinds of programs with lots of lines of code, and we'll want to save it so we can use it again. So we won't stick with the console, but that's kind of the point of it and what it can do. You can just do kind of Python on the fly. But now we can come to the main.py file and begin to put the code in that, and then write it and run it as we would usually do anytime we actually use Python. So let's come to my main.py file. Let's see if we can do the same thing. So I'll put a couple, lines of code. And one thing that we'll notice is now that we have this, we can write multiple lines of code. And the way that we actually execute this now is it's automatically saving. I don't have a save button, so this is kind of saved in my my project in Replit, so that's fine. But when I want to tell Python to run the file, I can use this button up at the top, and then it'll kind of wipe clean the console and print out anything that needs to be printed out from main.py. And what we'll notice now is it actually looks like it didn't do anything yet. And that's because in the console, anytime you do something, it's always going to print out the value of like the one line that you did. But in a Python file, you could have a million calculations and things going on, and you won't want every single thing being printed out to the console, because that could write a whole book of just all the calculations and things. So in actual Python, in a Python file, we need to tell Python explicitly to print it to the console and not to kind of do the math behind the scenes and not really save it and show it to us in any way. So all this math was done, but we just need to tell Python to put it to the console now. Let me move this. So the way that we can do that is with the built-in print function. So a function is something that's going to take some value that we give it. And in the case of a built-in function that Python just comes with, it's going to do something that Python is defined to do. So in the case of the print function, it's going to do exactly what it says, just print it to the console so we can see the actual values and things going on behind the scenes. So anytime we use any function in Python, one that's built in, one that we make homemade, which we'll see at the end of the class, we just use the name of the function. So this is the print function. And the way that we know it's a function is that it has these parentheses on the end. So that means it's a function. And the reason that we have these is that inside the parentheses, we can put what we want printed out. So that's the kind of box that we put the inputs to the function in. So print is going to do something and then print it out. So we need to tell it what to do, and then it'll print it out as its output. So I can put kind of anything that I want in the print function. So I can do something like this, print 2 plus 2, and that finally actually comes out now. We can keep going. We can just print a single value if we want. So we don't have to do math. We can just print the data objects themselves. You can see now that I have 2 print functions. It's just going to send them both to the console once I push the play button, so that's good. And not only can I do a couple print functions stacked on top, I can also just do multiple inputs to print using a comma. So anytime I put a comma in the print function, that means each kind of thing separated by the commas is its own kind of entity, and it'll print them all out separately. So if I do this now, you can see I got both of those. And then with this last one, it's just saying, okay, print is going to take 2 divided by 10. And 2 divided by 10 is just going to be computed by Python. Print itself is not doing that. 2 divided by 10 just automatically computes because it's a math equation. And then Python is going to say, it's going to take the 0.2 that is printed out. And then it just puts a little white between each comma out value that you put in. So it's going to say, I'm going to do this next, that equals that. And then finally, we'll do 6 times 6, and that's going to be equal to 36. So the print function is going to be really useful. We will be printing out with almost every example that we do, so we can see it come out in the console and we know what's going on in it, and it did that what we want. So print function is quite useful. The second kind of actual Python code that we'll see besides this built-in function is what's called the comment. And if you know any type of programming language, and even non-programming languages like HTML, CSS, and things, a comment is just a way of kind of putting something in my Python file, but telling my machine that it's not actual Python code. We can kind of think of it as like a sticky note that only I can see in my Python file. And I don't want Python to kind of execute it or think it's Python file to be a Python code to be done in any way. So in Python, we use a pound symbol or the hashtag, and anything following that won't be computed by Python, and it'll just kind of be viewed as plain text. So if I do something like this, you can see it's kind of grayed out, and that means nothing is going to happen to it. It just kind of floats in the file, but it doesn't get computed in any way. So that's a comment out. I can comment out a couple of these old lines if I want. So I can kind of keep them in my file and see my examples if you want to take notes. But now it's only basically doing these couple lines of code because Python knows all of this is not being done in any way. So that's the comment. And then one last kind of way that we can use the comment is I said anything following the pound symbol is a comment. So we can actually put a comment on the same line as we do some actual Python code. And the second half of the line past the pound symbol will be commented out, but the initial bit of the line won't be. So with this, we still did the print 2 plus 2 plus 2, but this bit isn't being commented out. And I can also just use this to take notes. Print function. So if you want, you can begin to comment code and just take basic notes, and it won't mess up the file in any way. How to do math in Python. And then you can comment the code, as it's called. Okay, we'll do one last example. So up until now, we've just been doing kind of quantities and math symbols. But one type of data object, which we'll talk about and explain in a little bit and use in the second class on, is a different type of data. We've been using like quantity type data, stuff we could do math with. But if we put something in quotes, that's going to mean it's a string or a piece of text, and then we can't do math with it. And it's basically just some like English or some plain text, which is a different type of data. So if we take a look at this, if I print 10 plus 10 inside quotes, what that's going to do is just print it out as a piece of text. It doesn't recognize that now as actual math and actual quantities. So this is a string, a piece of just text. And if we want, we can use that in combination with the print function to kind of add notes to the console now. So what I can do is do something like this. 10 plus 10, that's my string, that's my text piece of data. I can put a comma, and then I can actually do 10 plus 10, and actually let me put an equal sign like this. And now when I print this line, we can see that I get like a piece of text, and then I get my calculated result at the end of it, which is this piece. So this is printing a string, then a, we'll call this a math calculation. So we'll talk about strings in a little bit, but just so you know, if you want to begin to take a lot of notes and just practice on your own, you can begin to do that. And then one last thing we'll do on this slide is what happens if we get a bug in the code. So we can see I push play, I get some red text, and I don't get my usual results. And Python is good, and it usually tells us kind of exactly what's missing as long as it's a simple mistake. So we'll just take a look at this so we can get the feel and not panic when we see something like this. So this is what it usually looks like. It says, what file did I just execute? My main.py, that makes sense. It tells me what line the bug that it found was on, and that's kind of when it crashed. So it says someplace on line 15, something is not quite Pythonic, and that's why it couldn't actually compute. And then at the bottom, it usually says what it thinks the bug is. So in this case, it exactly identifies it. We had a print function. We opened the parentheses to say this is what's being input to the print function, but we didn't close it. I backspaced it. So it didn't know when to finish putting stuff into the print function. So it just wants me to fully close it. Then I can push my play. And then we get back to Python running as it should. So that's what we might see. You might have different kinds of bugs that come in. Like if we take out this plus symbol, let's see what happens. So again, we see we probably need something in between these two tens. If we put a comma, that would be fine. But in this case, it's saying invalid syntax. And then it actually says maybe you left out a comma, but maybe what we actually left out was, the math symbol that we needed. So in Python, bugs can be quite easy to identify. Come back to the code, know exactly what line to look on, and fix it as you need to. Okay. So bit of notes on this page. I'm going to blow it up so it's big. So we've seen two pieces of types of data in Python now. We've seen, like quantities that you can do math with, and we've seen these pieces of text, which I've just called strings. And now we'll talk about kind of all the basic data types in Python that we'll be seeing. A lot of them we'll be seeing today, actually. So what we've seen up until now, we've seen what's called the int. This is two int type data objects. An int is just integer, and that's any whole amount. So anything from -infinity to 0 to +infinity, that's an int. And then we actually have two types of kind of mathy type data. We actually have what's called a float. And that just means any quantity with anything that has a decimal point is technically a float type data object. So even though this is 10.0, it is a whole amount. But since I gave it that 0.0, that's actually not the same as just 10 itself. Bit of a small thing. It's fine if we kind of mix and match ints and floats. So if I do something like 10 plus 5.5, even though that's two types of data objects, since it's both quantities, it's totally fine. I can kind of mix and match them. I do an int plus a float, and then I can do that, and it automatically makes the result 15.5 also a float, since it needs that decimal point. So we have those two types of data objects. The one that we kind of just added at the end, anything is inside of quotations. That's going to be my string. So that's any text, basically. And that includes things like digits and math symbols. So if I put it in quotes, Python ceases to recognize it as just a 10 plus 10 math equation and just views it as text. So we can see it's not calculating it. It's just spitting it back out and printing it as exactly as it is. So we can't do math with strings, but we can do things like that. We can kind of put, any actual, alphabetical text in it, any symbols, math symbols, punctuation. As long as it's in those quotations, we can print it out to the console. And one thing I'll just mention, since you might see it out in the wild, you can do it with both types of quotations. You just have to be consistent. So in this case, I do the double quotes. In this case, I do single quotes, both the same exact thing. The one thing that we just can't do, because we always want to be consistent in coding, is we can't do like open double quote and then end with a single quote. That's going to mess it up, and we won't get into exactly why, but we always want to match them. So it's best to just stick with one. I tend to just use double quotes, and you can just, pick one and stick with it. So that's 3 types of data, of the basic main ones. We have 2 math ones, int and float. We have any type of text data, the string. And then the last one, which isn't on this slide, but we'll see it in this handout, it's what's called a Boolean type. And that just means anything that has 2 possible values, true and false. So that's kind of all we need of the basic data types. And then beyond those basic data types, what's left in Python is basically just collections of these data objects. So we actually saw a data type that's what's called a collection, or what's called a list. If I go back up to this, we can now identify this as a data object, and we'll see how to make name data objects in a minute. But we can see we have some float values separated out by commas, and we've just kind of put them all in the same bucket. In this case, it's something called a list, and it's just a collection of multiple data objects at one time. So that's all we kind of have left. We have the basics, the math, the string type data, the Boolean, true and false. And then beyond that, it's just different ways of putting them in buckets. So we can do things like this, have a whole bunch of data in one place, and then do something to all the data at once. So that's kind of all that's left with data types. And then we'll add on one last thing on this slide, a new type of function. We've seen the print function. This new one is called the type function. And this basically takes an object as its input, just like print takes some value as its input, and it's going to give back a special object or a special result that's just the type of data that value, that object is. So this is what it looks like. I could do something like this, type 10. When I push play, we'll see that, again, I need to actually print it out to the console. So we could do this. We'll do this the simple way. And we'll just say we want to take type 10 and print it out. So we can just stack it inside of the print function itself. So what this is going to do when Python sees this line of code, it's going to look inside print's input. It's going to say type 10. Okay, what is that going to give back? It's going to do that. And then it's going to do kind of this outside wrapping function of saying, okay, print that out now. So when I do this, we get this funny looking thing, but basically it tells us what this is. 10 is an int. I can put a couple inside, 10.0. Let's see what that is. Let's see what type 0 is. Type, -1, type hello. And then we can stack those couple, and then we'll see they all kind of look like that, but we see we have an int, float, int, and then the string type, just abbreviated. So this is how we can check what something is. This will be useful to actually run code. When you get into complicated functions, you won't just be checking things, but you'll be using this to check data types and things like that. So it'll be useful beyond just kind of checking while you get used to data types. And then one last thing I'll mention, now that we've kind of had all these data objects tossed at us, one thing that we'll notice is that when we want to mix and match data types, that's when we could also run into bugs. So if I want to print something like 10 plus 10, we can see we get a bug happening. And we can see main.py, last line of the file. And it's basically saying we have a type bug, and it's a little confusing what it exactly means, but we can get the gist of it saying we can't mix and match strings in ints. So we can't add the text 10 to the value 10. So that's when we might come into a bug. So we might have to do something like this. Then we get 10 plus 10 is equal to 20. But we could also do something like this, depending on what we had intended. We can kind of, instead of adding 2 pieces of text, what we can do with text is we can kind of glue them back to back and just make a new string that's both of them combined. And we'll see that when we get to strings. But the point is, just don't mix and match different data types, with the exception, again, of ints and floats. Those obviously you can mix and match totally fine. Okay. So now we have quite a bit behind us. We know how to send stuff to the console so we can actually see what's going on. We know how to do, types of math. We know how to check the type of objects or the type of values that we have. But we've basically just been using Python to do calculations. And that's basically the same thing we could do with a phone and just opening up the calculator app. So that's not quite why we want programming. So up until now, we've just been solving problems in Python. We've been needing to solve 10 plus 10, 2 divided by 5, things like that. And that's just a specific problem that we have that we do once, and then maybe we don't even need to save the file because we just solved it that one time. But what we do in programming is we write actual programs. And in that case, instead of calculating a specific thing, 10 plus 10, we want to write code instructions so we can solve a given type of problem with any given inputs. So we could come into this and do 2 plus 2, 5 plus 5, 10 plus 10, but each time we solve something, we have to make some new code. But with a program, what we can do is say, instead of just doing 10 plus 10, let's add box A to box B, and then the values of box A and box B could keep changing again and again. But we'll just have that instruction add A to B, and we can just use that code again and again to solve a type of problem. In this case, just like a simple addition problem. So that's what we'll be doing in Python. We want to write programs, so we want to make instructions in the Python file so that we can kind of give it any inputs and use the same code again and again, just changing the values, but having the same code of add this to this, do these couple steps, things like that. That's all going to be the same. We can just change the value and then use it again and again. So let's do a simple example, again, of just a basic problem, and then we'll see how to make it in a couple minutes into a program that we can use again and again. So I'm going to come into my file. You can go ahead and keep the notes that you have, but I'm just going to clean mine up. You can also just use comments so you can keep the notes, but it won't clutter up the console with print messages. So we'll just do this second one. So we just want to write code to find the total cost of a meal plus the tax plus a tip of 20%. So we can come in, you can see I have it on the side, but I'll just kind of explain it and type it out as we go. So I'm going to call this a problem. Find the total cost of a meal plus tax and tips. I just have a little bit of commented code. I can kind of add any amount of white space that I want at this point, kind of up and down, so I can put a couple lines between things. That's totally fine. Just like it's fine to add a couple white spaces in between. Best to be consistent and make it look neat, but that won't actually break anything. So I'm just going to put a couple spaces in between. And what I might do is just going to kind of all be one line of code. I'm going to say print, and then I just have to put in the values of my meal and things directly. So we'll say like my meal was $21.57. That was the cost of the meal. I want to add the tax rate. So I can say I want to multiply that times 1.06625. So that's going to add a little bit of tax to it. And then I'll make a kind of long math equation. I'll say again, let me take 21.57, multiply it by 0.2, and then I'll kind of add the tip onto the whole cost of the meal, and we'll make one big thing at the end. Print that out. Looks like that's the cost of my meal plus tax and tip. We can add a couple lines of code. It's always good to do this in any type of coding, both at the simple level and actually especially when you have hundreds of lines of code, different things going on. You'll want to comment the code to say exactly what's going on. Because if we came back to this Python file, we would have no idea what's going on with this. We don't know what 2157 is. We don't know why to multiply it by this and what this is. So in this case, I'm just going to put a comment saying what's going on. So it's going to say calculate total meal cost times tax plus tip. And that's just kind of like my little side note, my post-it note, saying what this is beneath it. And I can also clean this up one extra way. I can add a string in front of my actual calculation. So it comes out in my console and says what this is. I can say total cost of meal is equal to, print that out. And we could see we get this. And I can even put like the money symbol like that. And then we can see it comes out like that. So that's an example of a problem. And as we can see, anytime we change the cost of a meal, we'd have to come in and basically rewrite the whole code. If we went to a different state, we'd have to come in and change the cost of the tax, and same with tip. So in this case, we've used Python to calculate something, but it's not useful to us again and again. So that's what will kind of lead up to making reusable code. Okay. So as we just saw, we've been writing values directly into the code. So this is a value and its type is an int, or actually a float in this case. This is a value, it's a string, and the value of it is just the text that it says. So we've just been putting values straight into Python. But what we'll need to do is begin to make data objects. And what a data object is it's basically like a box that we can have data inside so that we can do a couple things with it. So let's talk about what components make up a data object. So they have three components. One is just the name of the object. So this is like, well, actually, we can see the examples on the side. So we have some data objects, and we'll write these in a second. But now we can see meal, tax, tip, total. Now we have names on these objects. So when we have the code in Python, we can actually see this is the meal, this is the tax, instead of needing to put all these comments to explain what's going on. So the name is useful in a couple ways. The second thing, the value, that we know because we've just been using values up to this point. So an object is a box with a value inside of it. So 2157, I can put that in an object like this. Data. And this is how we make them. We say the name of the object. We just use an equal sign, and then we just spit out the value like this. So this is an int data object. We can do the same thing with different types of data objects. So with a string, I can just do it like that. So now this is a data object / variable. It's also called, it's a string. Same thing with floats. I can say tax is equal to 1.06625, and that is a float data object. So now I kind of have the same thing that we begin to see why it's useful. I have labels on things, and that's useful in itself. And now the last thing that we need to know is all of these objects that we just made all have a specific type associated with them. So this is my int, this is my string, this is my float. And we can kind of think of that as like the shape of the data object box. So when I make a data object like this, I have a box, but until I give it an actual value, it's kind of typeless. It can kind of be anything until I set it equal to some value. But once we have them, we can come in and do things like this. Instead of printing out the values themselves, we can see anytime Python sees the name of an object, it's going to go back up the file and see the last time that I made the object, last time I like updated it, if I've been adding things to it, and it's just going to swap it out with the value on the fly. So now we see these begin to make, it begins to make sense why to use data objects. We begin to use the sensical names of what things is. We can use things again and again down the line in the code. Because up until now, even though we calculated the total cost of a meal up above, we could see that we printed that out, but we didn't actually save it kind of in Python anyplace. If we wanted to take the total cost of the meal and subtract it from some some idea of my wallet, how much money I have. I haven't saved the cost of a meal, so I can't kind of do multiple things. I can kind of do one thing, it computes it, and then I kind of forget about it. So now that we have objects, we can save them. We can use them again and again. It's labeled nicely. So this begins to set up the basic ideas of programming and writing instructions that we can use again and again. So now that I have this, you can see that I can do multiple things with it. I can use meal and tax once just to print out the values. And then I can use them again to actually do the math, and I didn't need to retype the values each time. The data objects. Yep, so everything, even the collections, like the lists that I talked about in a little bit, it's always the same. Some name that you make up equal to the value. And one thing that we need to know about data object names is that we don't need to put them in quotes. If I put it in quotes, Python now thinks that's a value itself. So I can't put it in quotes. So if I want to name a data object, it would need to look something like this, just by itself. But one thing that we can't do is we can't have any spaces in the name. So you can see I have a syntax bug. So what we usually do in Python is we make data objects like this. We use the little underline to act as white spaces like that. So this is how we can name things. We can use like digits in things in data object names, so that's totally fine as well. That's still good. But one thing we can't do is something like this, one data. That's not allowed. I can't begin the name of an object with a digit. It would have to look something like this instead. It just has to be at the end. So you have to begin with something alphabetical. Yeah, so no spaces. This is called snake case. That's what we use in Python. It kind of looks like a snake if you kind of space these all out like that. So you can use digits, but not at beginning. And then one last kind of convention is that you can use capitals in data object names, but in Python, convention is to use all lowercase. Sometimes you'll see all capitalized data objects, but by convention, those mean some specific type of data object. So it's best to just do them all lowercase like this. This won't break anything, but it's just kind of convention. Everybody who writes Python does the same thing. So if I saw a data object like this, I would know it's just a data object. And if I saw this all capitalized one, I would know, since everybody does the same thing, what that means on top of just being a data object. Okay. So let's go back and do the same problem we just did, but now as a Python program. So this was my problem up above. And now let's write kind of a program to do this instead. So I'm going to make a couple data objects like this. And now I can come in and put in my actual values like this. And this is how we usually do a Python program. So up at the top, you would define, meaning set, all the data objects and values, because you can't do any math until you have the thing that you need to do the math with. And then the second thing is, run the calculation in, most of the code. So down below, we would say, we would still want to do meal times tax. And then maybe we want to add the meal times tip to it. And I could space these out a little bit just so it looks conventional. And then I could just print this if I want, and that's fine. But what we might want to do instead of just printing it out is do all that math and then make a new data object called total, and then we'll save it in that. And then not only can we just come down and print it down below, but if we need to keep going on and using that total to do a couple additional calculations and things, we have total actually saved, so we can use it again and again to update it and do different things to it. So let's see if this comes out. Yep, yeah, so we just did this. Now we kind of have a mini Python program. And now we only have to change a couple things. We just have to change the actual values of things themselves. So I can come back up and just say, this time instead of 21.76, my meal was, 50.87. I just have to change that one thing. The rest of things I can just leave the same. And then I can use the same instructions to kind of calculate the same type of problem. But now I'm going to take the new inputs and give me a new output in the end. So this is the kind of key idea behind all programming. We want to kind of set data objects. And then this doesn't mean anything to us. We need these specific data inputs to calculate this. But since it's kind of vague and it's just an instruction to do a calculation based on some specifics, as long as we just come up and change these specifics, we can run this code with any type of data we put into it. And we can do, if we have a whole bunch of calculations, we can do all of these lines of code using meal and tax and tip and total. And we only have to change the value in one single place since we just set it at the beginning. And then anytime we use it again, it's going to be equal to what it was set to. Oh, and by the way, in addition to just like the handout itself, these couple links that we see will take you to websites, which will teach you everything that we do today and stuff beyond that. So W3 Schools is a good site. You can see it has a whole Python introduction module. So it's all the stuff on the side teaches the basics. A lot of what we do in this class will do all this, but you can come back to review and see what we missed. And the good thing about it is that you can see examples of code on the website, and then it has its own kind of IDE to practice and write code in to practice what it teaches. So that is all those links in the handout. Let me just find my place again. Okay. So what we've just done is we basically made a program. So we had, in this case, just one line of Python code, but it could be a whole bunch of lines. So the next thing that we'll need, kind of stacking onto the idea of using data objects to do things again and again and save things, is the idea of a custom function. So let me take some of this away. Okay, so a custom function, we've seen functions that come built in. We've seen the print function. We've seen the type function, and all it does is it looks like something like this, the name of the function, and then parentheses, and inside of that, you have an input, some data that you give it, and then it's going to spit back out some output, something that it calculated, something that it did. So we'll be looking at how to define these functions and then call them to actually run the code. So let's do a basic one. So with functions, we have two steps if we want to make one homemade. So we want to define the function, and then once we write all the instructions, then we can actually call and execute the function. And the reason that we need to define it and then actually call and run the function is that when we call it, we will give the function specific inputs to calculate a new output based on the general instructions. So just like the example we had a second ago when we had total equals meal times tax plus meal times tip, we'll basically be doing the same thing, but we'll just be putting it inside a new thing called a function so we can use it again and again. Once we set up a few examples, it'll kind of make sense why to make a function instead of just doing what we had just done. So to make a function, we use a piece of Python vocab, which is def, and that just means define. So I'm going to make a function. So I say define, I'm defining some function, and you can name it anything you want, just like you can name a data object anything you want. So I'll just name it function name. And then we open up parentheses because we want to say it's a function again. And then we'll put a colon at the end. And this is kind of the heading of everything that's inside the definition of the function. So inside the parentheses, we can again say, like when we call the print function and we give it a couple inputs, someplace in the Python code base that Python gives us, they have something that looks like this that says exactly what print is doing and how they make it jump to the console. So this is what print would look like. So when we make a function, we want to say, I'm expecting an input 1. I'm expecting an input 2. You can expect or ask to get as many inputs as you want. We can also just do a single input, and we can also do no inputs if we just want to call the function, and then it's always going to do the same thing. We don't need to give it some specific value to calculate something. We just call it, and it does the same thing again and again. So a function name, and then something that's convention, though you don't have to do it. It won't break anything if you do. Is this triple quotes? It's a type of comment that we put just below the definition of the function to explain what the function is doing. And it's kind of into the high-end side of Python why we do that. But it's just useful anytime you come back to a function you made, you can come to this little type of comment and see what it says about it. You'll explain what the function does, maybe what inputs it's expecting, and what it's going to spit out at the end. So it's also a type of comment. This is not going to do anything. It basically just sits in the Python file so you can take a look at it and help you out. You'll notice now that I'm writing the function, I'm indented. So this is when we begin to indent in Python. And the reason that I'm indenting is a way of defining all the code that's inside the function itself from code that's just down the line and is not associated with the definition of this function name that I had just made. So in this example, I tell Python I'm defining function name, and it's going to say, okay, anything beyond this that's indented is kind of inside function name. And as soon as I outdent again like this, I'm just on to the next piece of code, and that's not associated with the function. So the indenting kind of defines like the scope of things and what belongs kind of inside what. That's the point of the indenting. Okay, so let's do an actual kind of useful example of a function besides this vague one. So I'm just going to make a function that says hello, and I'll just call it the hello function. So I'm going to say def hello, says hello. That's just my explanation. And then since it says hello, I know how to do that. So I can just say print hello. And then I'm going to do something like this. This piece of Python vocab basically signals this is the end of the Python function. So at this point, you might spit something out of the function, maybe something that you calculated and that you'll accept when you call the function. We'll see an example of that in a second. But if I'm not spitting something out of the function, I can just kind of leave it blank like this. I like to just put a comment to say nothing's coming out, nothing is expected to output. So I don't see that like kind of blank line and think I missed something. So I tend to just put comments. So this is my basic function. It's not accepting any inputs. It's not spitting anything out. But when I call it, it is going to execute one line of code. So that's half the function, just defining it. If I push play now, we can see that nothing is happening. And that's because I've just defined the function. So Python, when I push play, it scans this whole file top to bottom. And it's basically reading in all the instructions and all the calculations that it has to do. And in the case of a function definition, it's basically just memorizing what to do if this function is called, if and when it is actually called. So it just knows how to say hello, but we haven't told it to say hello yet. So the second thing to do is to actually call the function once we want to do it. And in that case, we kind of know how to do it. We've been using the print function and the type function. And to use a function, just write the function name plus the parentheses on the end, and to say it's a function. And we'll just say no inputs, so we know this is supposed to be blank in this case, unlike the print function when we would need to put something inside of it. So now I can push play. And then we can see now it's actually executing that code. And now we see the usefulness of functions. We did this whole bit of extra code, and then we called it when we could have just said print hello. But now I can come back down and call the function as many times as I want in any place that I want. And each time I call it, it's going to execute the same code again and again. So that's the usefulness of functions. We can write something once and then use it as many times as we want. So that's that. Let's go ahead and change this function a little bit. So now we can input something to this function and maybe output something as well. So we kind of see a fully fledged function when you would have all kinds of data being exchanged. Did you need to leave, Alice? I just wanted to check with you. Okay, yeah, I didn't want you to miss the clock. Oh, yeah, that's fine. Yeah, that's fine. Okay, so let's change up this function a little bit. So right now we just say do hello and it does it. And now let's change it a little bit. And let's say now we want to expect a name to be given to us. So instead of just saying hello, we say hello to someone's name. So we can come back up to the definition. We can kind of guess what we would have to do. We would say hello, put a comma, put the name, and then we could put a comma again. Then we maybe put an exclamation point to kind of build a sentence with that static string text and the dynamic value object in the middle. But we still have to do a couple things. Up in the definition, we now need to say we expect something called name. So if you call this function, you have to supply us with something called name. And now what we need to do, and actually let's see what happens when we push play. We can see we can't run this code because now hello is expecting something called name. So if we call hello and don't give it that object called name, Python crashes because it needs to do something with name. And if it doesn't have it, it can't do anything. So we can't do this. The definition is totally fine now. And now I just need to come down to hello and say, maybe say hello to John, maybe say hello to Susie, maybe say hello to 10 plus 10. Let's see what that does. And we could see, yep, it's behaving exactly as we want, even though in the last case, it looks a little funny. So I said, call the function hello. I'm going to give it John. So Python says, okay, I memorized the instruction to hello. And it's going to come back up and say, okay, hello is called. The John that was supplied becomes the object called name. And then it says, okay, let's do the code line by line. It says print hello, puts in name, which is John in this case, and then the exclamation point, runs that. So that line is done. Then it comes back down to this line, says, okay, do hello again. So it comes back up, says, okay, I'm executing hello. In this case, name is going to become Susie because down below I said it was Susie. So name is now Susie. Hello, Susie. That comes out just fine. And in the last case, I said hello, 10 plus 10. Like we said, anytime we just kind of have this little simple math equation, it's just going to instantly calculate to the sum of that. So I'm actually calling basically hello 20. And that's an int that I'm giving it. And then it comes back up, says, say hello. It's putting 20 as name, but that's totally fine because Python is not human. It doesn't know to expect that name should be something like a name, or at least some type of text. If I supply it with an int, it just makes an object called name, puts in the value 20, and its type just becomes an int because that's what I supplied it. So then it says hello, spits out 20, and then the exclamation point. So we can begin to see Python does exactly what we want. If we want to kind of prevent things from happening, obviously when you make websites and complicated things, you would want to catch something like this. You would want to come into the definition and maybe say, catch any non-string type data and don't run the function. But we won't get into that today. But basically the point I want to make is anything that you give it, it'll just use it as you give it. So that's why we need to be consistent about how we call things, what we give it, and why it's not incorrect that this came out. That's exactly what we gave it. So if we wanted to code in only accept alphabetical names, we would have to know the code to do that and add a couple lines of this to kind of check when something is happening and maybe prevent the function from running if we don't have like an actual name. Okay. So that is, now we have kind of a fully fledged function. We give it an input and spit it back out. Let's do one last or two last iterations of a function. Let's say name1 and name2, just so we can see some examples. Now we'll just make a function that accepts two inputs. That's totally fine. We can just change it a little bit. And then we just need to come down and add a second input. And that comes out just fine. And then one last thing that we'll give an example of, though it kind of doesn't make sense in this situation, is what if we want to do something in this function? And actually, we'll go ahead and just do a quick new type, a new function. So I'm going to say def addition. And I'm just going to make a simple function to add two amounts. And we'll just say total equals A plus B. So again, this is just instructions to do a type of problem given some A and some B as we define it. And now in this case, we want to spit back out the total anytime we use this addition function that we set up, that we could be using a million times if we need to. So we'll come back down. Now we'll call the addition function. We'll supply 10 as A, and the second thing, which will be B, we'll say is 20. And let's see what kind of goes on. So we can see nothing went on, and that's because maybe we need to print it out. We always need to print stuff, so maybe it's just not coming out that way. So we can print that out. Then we can see, yeah, we can see I call addition. So I look kind of inside and say, run this. So I come to addition. I have my A and my B, which is 10 and 20. I do this. Total is going to be kind of spit back out the back end of the machine that is this function. So when I do this, I go to the function, calculate it. Then this line that I've highlighted kind of becomes total. And then I can print that out like that. But the best way to kind of think of it is maybe not like this, but maybe something like this, when addition is going to become some value. So since it's just going to be a value in the end, I can just set it equal to a new data object that I made. And then I can come back down and just print that out like any old object that we've been making. Maybe I'll check the type of it too. We can run this. And now we can see, yeah, we have a whole lot going on. We have these, complicated ideas to make functions and definitions, but it's still just doing simple math, like what we said in the beginning of the class. But now we just have a lot of steps, and now we can save data. Now we can use bits of code multiple times, as many times as we want, and all this good stuff that you need in programming to do complicated and lengthy tasks. So this line, we want to spit something back out. And then one last thing that I'll show you, that we won't use it that much, is just like we can accept as many inputs as we define, we can also define a couple outputs if we want to spit back out a couple things. So just like I can just kind of comma and accept two inputs, I can put a comma and put out a couple outputs. In this case, addition is always going to give you the total, and it's also just going to give you, and I didn't even put it in an object, I just gave it the value hello. And then we can do something like this. And again, this is something that we won't use too often in this class, but it's just something good to know about, to kind of see, yeah, these functions can kind of do anything. You can put any amount of stuff in, accept any amount of stuff out, and inside the function, do all the calculations and changes to data that you need. So we can see addition, give it 10 and give it 20, come to my definition, 10 plus 20, that equals something, put it inside an object called total. Then on the last line of the function, it spits back out total, and it's just always going to spit back out the same hello. That's going to be consistent anytime you call the function in this, kind of silly case. And then we do all that. At the point that we run the function and get to this line, we basically swap this out. This is how Python is kind of thinking. It's going to swap this out with the two values. And then we just kind of say output is equal to value 1, and value is equal to value 2 from the function itself. It's a little complicated when you juggle a couple things at once, but again, I just want to point out functions can do kind of anything that you can imagine. So that's where we want to use them. Okay. Oh, and one last thing that I'll mention, actually the two last things on the ideas of functions. Let's see. When we execute any Python code like this, it's always going to run that code. So inside the machine, it's doing addition, supplying at 10 and 20 2 times. But because in this case, we didn't save the values and we didn't print the values, it's basically just calculating them and then immediately like putting them into the trash can. So you can do this just because we want to spit back out 2 outputs. Doesn't mean we need to accept them. So we can just do that. And that's totally fine. We don't need to accept the outputs like we need to supply the inputs. We can just say run this, and then instead of setting it equal to something, Python says no data objects to put it into, which we would have on this side. So it kind of just puts it in the trash can. So you can do that, just so you know. And then one last thing I'll mention, kind of a big thing that you could stumble into is this issue. Okay, so I've just added one line. So I've tried to add 1 and 1, and we can see that I got a bug. So it says I have a traceback. That just means a bug in my code is in main.py. It's on line 18. So this is the issue. We can see I'm calling it the way that I should. I give the name of the function, give it the inputs that it expects. So I don't know why that's wrong. But it says we have a name bug, and it says name addition is not defined. And so what it basically is saying is that when and let me delete this real quick. When Python reads this file, each time I push play, it begins with a clean slate. So Python goes top to bottom. So if I use the function ahead of defining it, Python comes to this line. It says, okay, I want to take 1 and 1 and do the function definition. But since Python has only scanned these lines of the code, it doesn't know what addition is, doesn't know how to do it. So it just crashes like we see. So in addition to usually putting variables at top of like the Python file so that we can then use them, we also want to put kind of at the top or in the middle of the file, we want to define the functions that we'll use at the end of the file. So we want to take this, put it down below, and then if we push play, it runs fine. And that's just because we always need to define things, and then we can use them when and if and how many times we want. So that's a key point too. You want to define the functions ahead of actually using them, else you'll get a bug. Okay. If we have any questions, I know a lot's coming at you, especially if you haven't done any type of coding. Hopefully I've done it simply enough, but if you need to slow down, do these couple examples again, let me know. Yeah, go ahead.
Sorry, what you mentioned about the indentation?
Yeah,
I missed that a little bit. What was the purpose of it?
Oh yeah, so I'll do that again because that's a good point. So indenting, we can see I have my function definition, and then inside of it, each of these lines is, it's kind of a small space, but you can see each one is indented a little bit. So indentation you have to use in Python when it's needed. And basically what it does is, and we'll see it in a couple places, not just when defining a function, but basically it says all of this indented stuff belongs to the thing above it. So when I see this line, and then I see all this stuff indented beneath it, that kind of defines and tells Python all of this stuff belongs to the addition function definition. So it's basically just a way of boxing up and saying all this code belongs to this. And then once we go on and outdent on the next line, this is now just something completely new. And it's basically just a way of saying this is one complete package. like we see.
Okay.
Yeah.
Thank you so much.
Okay. Let's see. Okay, let's do a new type of built-in function that we have to kind of practice using those, and again, make a homemade function again. This one's quite useful to people new at coding. This one is called the input function. And it's basically the opposite of the print function. With the print function, we'll do an example. You give it a value and it spits it out to the console. The input function is going to kind of do the opposite. So I print hello, that comes out. But now we can see in my console, I can actually type. So what input does is it lets you just ask a question. So this input to the input function is just what shows up on the console. So it can be any type of text that you want. And then you can see we can click on this, type, and then click the enter key. And what that is actually doing is it's letting us put data from the console and save it in Python. So I can do something like this. Let that load. So I say, hello, what is my name? Let me say Matt, put that in. And then we can see I print out Matt. So what I've done is I've asked this question, gave it the string Matt. It saved it in an object called name. So that's just going to becomes a string object text. And then I can just use that anytime that I want. So it's basically, we can kind of think of it as the opposite of the print function. It's, I mean, it's the same thing as doing something like this. But the usefulness of doing input is instead of coming into my Python file and changing this anytime that I want to change my name, if I use input, then I can just kind of on the fly update the values in that one instance of using the file that is going to need some new specific value. So let's do one last example. We'll go back and do the hello function again and use the input function to kind of update it. So I'm going to say def hello, define the hello definition, parentheses, colon, that's my heading line, come back down, do this kind of definition special type of string, just as a note to me saying what it is. Let's continue to define it. So I'm going to want to, actually in this case, I'm not going to give it name because I'm going to use input instead. So I'm going to say we don't accept any inputs to hello down when we actually call the function. So don't need to supply it with anything at the time that I call it. And let me call it a couple times. Just set that up, but we won't use it yet because we haven't fully defined it. And then we'll come back up and we'll say, I want to have a data object called name. What is that going to be equal to? Well, let's just ask on the fly using input, what is your name? And then we can say print hello name. And then I'll just kind of end my function. I'm not going to output anything. So I'll just kind of leave this, this line blank. And now let's see what we can do with this. So push play. It's going to, Python reads this file. It memorizes the instructions, but it doesn't do anything yet. Keeps going, gets to this line of code and says, okay, let's go back up to hello and execute that function once. So I come up to hello, gets to this line of code, and each time it executes input, it basically pauses the program. So it's waiting on me to put something in. And then when I do, it can go on and say, hello name, since I just supplied that. And then I finish the function. So I'm done with this line of code. Then I called it again. So I come back down, calling hello. Let's go back up to the top. Let me do this again. So I'm going to say input, what is my name? I'm going to get a new name and then save it in a new object called name, where we can maybe think of it as replacing the object of name in this instance when we use the function. So in this case, John, finish that, output nothing. So we finished with this line. And then we just have one line left, call hello one last time, go back up to the top, see how hello is defined. We again want to say input, what is my name? Give it a name. And then it says, hello, Jen. Outputs nothing, finishes with this line, and then that's it. So that's input. We'll use it a couple ways. We can see in this example, and I'm not going to type this one out. I'm just going to kind of explain it since it's on the screen. One thing that input does is anything that you give it is always going to be a string type data. So let me move this and let me say output is equal to input some data. And then I'm going to print output and type of output. Let me see what it does. So I want some data. I'm going to input that. Let me get it like a 101. And now we can see I get 101 as my output. But when I print it, it's saying 101 is a string. And that's basically just how input as defined, even if I give it digits, even if I give it what looks like a float, if I do something like this, it's just always going to save it as a string. So even if I give it, 10, it's always going to save it like this. It's going to make a string by default. So that could be an issue if we want to do something useful with input, like maybe make a function like addition that we've just done, but ask for the 2 digits we want to add on the fly. So if we take a look at this example, and I'll move it to the middle, we can see this is the addition function that we just did a few minutes ago, but it's called add nums this time. So we define add nums, make a num1, make a num2, just input what is num1, what is num2. But since we get strings back, we wouldn't actually be able to add 10 to 20. We would get those like type bugs that we saw in the beginning of the class, because we can't add the text 10 to the text 20. They would have to be int types. But since input defines it by a string by default, it seems like we might have a limitation. But we actually have a way of changing the type of an object as long as it's kind of allowed to be a different type of object. So this is a bunch of new functions, just like print and input and type. These functions that we see on this side, the function int, the function float, string, and bool, what these basically do is take some value and make it into an int, make it into a float, make it into a string, as long as it's allowed to be. So let's look at a quick example of that. Let me give the text, see, like text 10 is equal to A, print out A and type of A. And now let's use this new function. So we'll say A is going to be updated. We may be able to say this new thing B is going to be equal to int A. So I'm going to take A and kind of make it into an int, make an integer if possible. And then let's go and print B and type B, and let's see what we can do with this new function and the float and the string and the bool as well. Let me cancel this out. So I'm going to comment this out so we don't have to deal with that. Let this load. So now we can see we defined the text 10. So this is a string, and we could see that's what it was. But then we just intified it. We just casted it, as it's called, or maybe like translated it, changed it into an int, save that into a new object called B, and now B is equal to 10. But now that's an int. So now we could do something. Now we can actually do math with it. So we can actually do B plus 10 if we wanted to. So we can see that's useful to us. And if we come back to this example, we can see the same thing. We want to add 2 digits to amounts that we get on the fly. So we get num1, num2. Since input gives us a string by default, we just need to cast both of these into kind of quantities that we can do math with. So we can see this little line looks a little bit complicated, but I'm basically saying I have num1, I have num2. That could be 10 and 20. But at this point, 10 is a piece of text and 20 is a piece of text. So ahead of adding them, I'm going to make them into a float, and I'm going to make this one into a float and make that one into one. Then I will add them. And then I also took the result and made it into an int. You can skip that bit. That actually I don't need. But basically I need to make them into an actual quantity we can do math with, and then we can get it back and actually do the math. The reason that I did float instead of int, let's actually take a look at that. So you can see if I so the way int behaves, if I give it 10.6, it tries to make it into a whole amount, which is what an integer is. So it just makes it 10. So that's kind of, it doesn't crash, but it doesn't behave as we want. So that's kind of like an invisible bug that can slip past you if you don't notice. But now if we take 10.6 as a piece of text and try to make that into an int, it says, you know, it has a decimal. We can't do this. So if we come instead and make it a float, then it'll definitely be allowed. And that's also fine if we just have a whole amount. We just use float because it can kind of catch any amount, because we could use in this addition function that we have, we might want to add 2 to 5.7. So we just want to floatify both of them just in case they have decimals. And then we kind of prevented any bugs from happening if someone puts in a 5.5 plus a 6.7, and we just use the int casting function, then they would both crash and we'd have a lot of bugs. So we kind of think ahead and say we need float to kind of prevent any issues from happening. So this is when we begin to get like a little bit complicated. This is a little less simple code instructions, simple math, and kind of thinking about the fact that we have data types in Python and we need to watch out when we mix and match them, and you know what data types can have what types of things done to them and stuff like that. So this might take a little bit to get used to, maybe a while to until you anticipate it. You know, you might try to write this function and you would get the bug, and then you would know how to go back and fix it. But eventually it'll kind of sink in and you'll know, even when you define this function without having executed the code and seen the bugs, you'll anticipate the bugs ahead of time, you know, because you'll be so used to thinking about data types and what things can go with what things. And this type of thing, you know, dealing with data types and things, this is common in all programming languages. But like I said, Python tends to be quite simple next to a lot of languages when you have to really define everything and you can't make any mistakes and all kinds of things. So it is kind of easiest in Python, I feel. Okay. This one, I won't write it out in the in Replit, but we can kind of see it's just a second example of a function. And I'm not going to focus so much on the code itself. This function is just calculating how many seconds in a day, and we can see in the function we just use input to get how many days, and then we can use that function again and again to calculate how many seconds in 10 days, how many seconds in 1 day, and so on. And we can see it's some basic math, and we print it out at the end and stuff like that. But the point is actually all these comments that I have in the code. So even though I have my object names and this kind of all makes sense, we can kind of read this code as plain English and it makes sense to us. It's not always going to be that obvious. So one thing that we can do is when we define the function, what we'll actually do is just set up all the steps of the code just as comments. We will skip the Python code and just do this comment, this one, and that one. Define all the steps that we need to do so we can really think about the whole problem and know that we have a correct solution. Then we'll go back and actually put in the Python code. But the second half of this idea is not only to use comments to set up the problem, but we want to leave the comments. So anyone who comes back to this, because you might write Python that you have colleagues looking at, that you publish on the web, it acts as a good explanation of what's going on in the code. Because again, this example is obvious, but you could have some Python function that's doing a whole bunch of crazy stuff. and you just want some plain English comments to say exactly what's going on in the code. That idea is called documentation, and it's pretty common across all coding languages. So we want to use the comments to set up the problem, and then basically leave them in, simple comments just saying what's happening to be useful to us and anyone who comes back to it. Okay. So we'll keep going. It looks like we might not finish all of this handout today, but we'll finish next time if we don't get to all of it. And again, any questions? I don't think I see any in the chat. Any questions, just unmute and let me know. So we have one last data type that we mentioned in the beginning. We have the ints and the floats. We have strings, which is just text. And then the last one, which I mentioned, but we haven't seen yet, is the bool, aka a Boolean. And that's just a specific type of data, which can only have two possible values. And that's, true and false. So when we think about code and we want to define all kinds of functions that do different calculations and things, one thing that we'll quickly realize is that we don't always just want to write, 10 lines of code and execute all 10 lines every single time. Sometimes we'll want to ask questions and say, if this thing happened, then do this code. Maybe if that didn't happen, don't run this code. Maybe say, if this is true, do this bit of code, but if it's not, just skip the rest of the code, stuff like that. So we want to kind of ask questions in a way, see if something is true and false, and then kind of have conditional logic. What should we do if this is the case? Maybe if that's not the case, we do this instead. Maybe we do nothing else instead. So we kind of want to have that ability to have a function which can behave differently depending exactly on the conditions that we have. So the Boolean is going to set us on that path. Just having a value that's true and false lets us kind of ask questions since we have that. So let's just kind of look at these Booleans. Actually, let me jump to this question. So the name of the website is W3 Schools, one such website. Lots of good free stuff on the web. And you can see, if you jump to it, you can see they have a whole bunch of how-tos on different coding languages. But you can see on the left-hand side, all the mini lessons that they have. And today in this class, we've done, this little bit of the how-to. But this you can go to. It'll teach you how to do it, give you examples, and let you practice on the website itself. So that's W3 Schools. You can look up. Okay, let me move this back. Get us set up. Okay, so we have Booleans, true and false, just like any object. So object equals value. So I can just name my Boolean anything I want. So I'm just going to call it my Boolean. And then it only has two possible values. So I'm going to actually do a second object beneath it called my Boolean 2. And on the right-hand side of this, we'll see the only two values that you can have when you want to set up a Boolean, true and false. You'll notice I didn't put these in quotes, not in quotes, because if I just have this and it's capitalized, Python sees that and knows that's a Boolean, that's a true, false value. It's not the same as this my string, which is just called true, which is just a piece of text. And just like if we had a piece of text that was like 101, we can't do math with that. In the same way, if we have this, we can't do logical questions with it because it's text and not that true false kind of switch that we want. So this is the two examples. We'll just quickly check that. So we'll say my Boolean, and we'll just check the type to see what that looks like. My Boolean 2. And we can see, yeah, it comes out as true. We could do false, and it's just the bool type. So that's pretty simple to know what it looks like. And now we can begin to look at conditional questions to kind of come to a true and false value. So we can ask questions, and then based on the true false, we can do different things based on the code and the values that we have. So down below, we can just make them, but we can also do something like this. My bool is equal to, and then we can kind of do like mathy type question things. So I could do something like this. And let me just print this out, and then we'll go back and explain it. So you can see this my bool, it came out to be false. And what I'm doing is I'm just asking a question. So when I do something like this with any of these like equality symbols from math class, that's basically asking a question, and it's going to compute to true and false, just like the same way if we did something like this, that would compute to some quotient, things like that. So is 3 less than 0? Well, that's false. So that's what's gonna be the value of my bool. I can switch this and say, is 3 above 0? In that case, it'll be true. So that's how I'll get that. So I got those two symbols. I can have the equal sign to say greater than or equal to. So if I do that, still going to be the same thing. But now if I swap this out like this, we can see that's now equal to true, because 3 is greater than or equal to 3. But if I had just done this, that would equal to false. So again, we know most of these symbols from math class. Do I have them in the handout? Yeah, so I have greater than, less than. We can ask the question, is equal to. So that's going to be, let me put this down below so we can see it. And this time I'll just, instead of saving it in an object, I'll just print it out itself. So is equal to is a double equal sign. And the reason it's a double equal sign is that the single equal sign already has a use in Python. The single equal sign means take this value and assign it to this object, put it in this data box. So we can't just do 3 equal to 2. We can think of this as is equal to, and that's going to ask the question, is equal to, not single equal sign. So we can have that. And then the last one that we can have is something not equal to something. And that looks like this. This is the newest one. This isn't like a math class thing. So exclamation point equal sign means is not equal to. So it's asking if it's not equal to something. So that's kind of how we can ask all the questions. At least when it comes to quantities, we can do kind of the same thing with strings, although we'll use strings in subsequent lessons. But if we do something like this, we can do logical tests with strings as well. So we can see this last one is equal to true. If I changed this slightly, even did a non-capital H, this one is basically saying, is this exactly equal to this thing? And in that case, that would be false, because we have a capital H and not a capital H on this side. But again, we'll just stick with the math today. But we can use these symbols with different types of data as well. Okay. So we have the bool, the true and false. We have the ability to ask the question to get the true and false. And now let's see what we can do with that result, depending on what comes out. Okay. So in this example, I'm going to ask, we won't do this example. We'll just basically say, let's set up a problem. We'll set up some data at the top. So we'll say data at top. So I'll say my wallet is equal to, I have 10.50 in my wallet. Let's say meal 1 is equal to $7.99. Let's say meal 2 is equal to $12.99. So we set up all those objects that we can use up above. And now we can begin to ask questions like this. So I'll say, is wallet greater than or equal to meal 1? So I can ask the question, do I have enough money basically to buy meal 1? And I can do the same thing with the second one. Would I have enough to buy meal 2? And we could see I have true and false. And now let's see, let's actually use this with the latest bit of Python, which is asking, which is using the if, the else if, and the else kind of vocab that we saw in the beginning of the class, all the vocab that you use with Python. So this is what it looks like. We say if we put some condition, and then as long as we pass that condition, meaning what we ask is true, then we will run the code that's in the if block, as we would say. And if we fail that condition, then we just don't execute the code. So we'll see an example of that, and then it'll make sense. So I'm going to set up an if block. And this is basically asking a question. So I'll say if wallet is greater than or equal to meal1. That means I have enough money if I get inside this if block. And you'll notice, just like a function, I'm now indented. So all of my lines that belong to the if block will be indented. And we'll come back to that in a second. So I'm going to say if wallet is above or equal to meal1. Let's go ahead and say, let's go ahead and print, you can buy meal1. And let's just check that. So we get that. And now let's just swap this out. So if we change this to meal2, we can see this doesn't happen at all. So if this equals false, then anything that belongs to the if block just doesn't execute at all. Python just skips past it. So that's why, just like function blocks, we need to indent, because now Python can see this is false, and I know what to skip because it's all indented below my if block. So that's kind of my cue of what's kind of in the scope of that. And if I put this at the end, we can see I'm still failing this test because I don't have enough money. I skip all of these, and then just like with function blocks, as soon as I kind of outdent again back to the kind of baseline on the left of the page, then I can just begin executing the code again because I'm now outside this if block. So that's just how we define kind of what is one block of stuff. So that's my if block. We can add a little bit to this. So I'm going to say we can buy meal1. Now let's actually update wallet and kind of subtract the money so we can actually buy that meal. So I'm going to switch this back to meal1. I'm going to say you can buy meal1. And now let's update this. I'm going to say wallet minus meal1. And now I'm doing this math, but when it comes to updating objects, I need to update the object. So this is what it actually is supposed to look like if we want to update wallet. So if I do this, and we kind of look at this right to left in Python a lot, I'm going to say, okay, I want to execute this code. So I'm going to take wallet, which is 1050, minus meal1, which is 799. That's going to be equal to what it is. And then if I didn't have this bit of code, it basically just calculates that, but then doesn't update anything, doesn't save anything. So what I need to do is say update wallet to be equal to what wallet was a second ago minus meal1. So this is how I kind of change wallet and update it. And then I can come back down, say print, you have wallet money left. And let's see what that looks like. I guess I shouldn't say money. And now we can see we passed the if check. We can buy meal1. We came inside the if block. If we hadn't passed, we would just skip past it. We did the math and we updated wallet. So now we know how to update values and continue to use saved values, update them and use them again and again. Then we just did a print statement. And then I finished all the if code because I was allowed to. And then as always, I just print this at the end because this is outside the if block. So that's my if clause, my if question. We have an additional example in the handout. But now we have a couple additional questions that we can ask. Actually, let's do one last. Let me see what I want to do. Let's do a new example a little bit. So I'm going to say wallet is equal to, let's say I have 20 bucks this time. Let's say my drink is equal to $8.75 a drink. That's how much it costs. And let's set up a question again. So if my wallet is greater than or equal to drink, then I will be able to buy a drink. Print, you can buy one drink. But now what if we want to like ask multiple questions in a row? What if we want to see if you can buy like 2 drinks? Well, let's come above it and say if wallet greater than or equal to drink times 2, we could do that, space it out a little bit. Print, you can buy 2 drinks. And let's check this. So we can see we passed both of these checks. We saved these into the machine when we ran the file. We asked this question. We have 20 bucks, so that's plenty. We can buy 2 drinks. Finish that if clause, came down to this one. Asked a new question. We can still buy a single drink because obviously we could buy 2 drinks. So then we can print this one out as well. But now we begin to see we want to it's a little bit inconvenient that we have to print these both out at once. What if we just want to print out this if we can buy 2 drinks? And obviously if you can buy 2 drinks, it doesn't make sense to say you can buy 1 drink. So can we only say this if that's the case and not this? But if we don't pass this test, continue to ask this and then say that if you at least have 875. So what we can do is we can do something like this. So I just added one little thing. And now you can see this now says elif, and elif is just an abbreviation of else if. That's pretty, plain English. So what I'm now asking is I will run the file. I'll say, do I have enough money to buy 2 drinks? That's now true. So I do this bit of code. And now else if implies if I failed this, then I'm gonna do this one instead. But if I use an elif clause linked to this one above it, if this one passes that I have highlighted, this one won't execute, even if this is still true, because I only want to ask one question in the sequence. So elif makes it mutually exclusive from the if in the chain above it. So in like an if elif chain, you would have an if, elif just below it. You can keep going and have a couple of these. Let me say, we'll make something called snack and make that like $1. You can buy 1 snack. Let's make something called snack and make that be like $2, something cheap. And then let's change my wallet to just be $2. And we can see we can buy 1 snack. And then if I go back up and just run this, since it's all if, elif, that's all in a chain. So if I pass this one, I'm just going to skip both of these completely. I won't even ask the question because it's mutually exclusive. If I change this to be $10, you can see what Python is doing is it's asking this question. That comes out to be false. So I'm skipping the if code itself. Then I can come back down to this. Else if I have enough money to buy 1 drink, which I do, I can print out this. But since I passed that one, I'm also going to skip this elif because, again, it's all mutually exclusive in this kind of chain of questions. So if elif, as many as you want, make it all mutually exclusive. So you only pass 1 true false test. And then as soon as you pass one, you can just kind of skip the rest of these. And that's opposed to if we just had if I just did something like this, I just ask all the questions. And as long as I pass the test, I can print them all out at once. So in different cases, you'll use if, and in different cases, you'll use if, elif, in kind of a chain, depending if you want them all to execute or just one, like the most or the highest thing to execute. So that's that. And then one last kind of component of the if, elif question ability we have in Python is the else clause. Let me just set it up. So we can do this. Let me play this and we'll kind of guess what is going to happen. So I have $10. I can buy 1 drink. So we can see it's still behaving the same way. It's all mutually exclusive, even the else. As soon as I pass one test up above, I just kind of skip the rest in the chain. But what I can do is if I have no money, you can see then I finally get to my else clause. And all the else clause is basically identical to elif, but I don't need a question. So you'll notice I have else colon instead of like else, wallet equal to 0. I don't even need to ask a question. As soon as I get to my else, if everything above it failed, I just execute that anyway at the end of it. So that's my else. And that's all we need to ask kind of any question in Python, just my if, my elif, my if, elif, elif, if, elif, else. You can kind of combine those in any way, depending on the stack of questions you have, if you need them mutually exclusive, and then you can do it the way that you want. So that's all in the notes if you need to go back and review, because that's kind of the heaviest concept that we've had, linking a whole bunch of new stuff at once and kind of all these ideas at once. It gets a little bit used to, a little bit of time to get used to, especially when you need to ask, do I use elif, or should I just use a couple ifs in a row? Okay, so we just have a couple minutes left, so I'm going to see, we'll go ahead and stop because the next idea is like a pretty big idea, these loops that we'll get to at the beginning of next class. But this is a good cutoff point. The next slide you can do as practice if you want now, right ahead of the next class, just how to make this little function. And I have the code of how you would do it on the side if you want to practice. But we'll go ahead and call it today. We still have a couple of minutes though, so if you have any questions, if you want to review anything we just did, we can go back and look at that now.